All right, today I'm going to horse around a little bit with some charging system stuff. You know, a lot of the times we have an idea that we think we know all that there is to know about a charging system because we hear a noisy alternator, or we check the charging system and it's not putting out, and we pop an alternator on there and that has taken care of it. And I learned early in my career that just throwing an alternator at one, that probably works about 90% of the time, but the other 10% of the time can smack you around if you don't know which way to go with that thing. There's a lot that needs to be understood by charging systems. There was a little Ford Ranger trainer vehicle that I used to have that I would put out there for those students, and there's one fuse in that 99 Ranger that or it was a 98 Ranger I guess, but there's one fuse that you could pull out that would kill the alternator light and the airbag light, but all the other warning lights would work. And I could pull that fuse and that would kill the power going through that warning light out there to turn on the alternator, because it uses that voltage coming through that light to turn on the regulator and start the alternator charging. And so people would get smacked around, and I'd say, look, that green wire with that red stripe needs to have 12 volts on it coming through that bulb. So the first thing you need to do if you're checking the charging system, switch on the key and see if the charge light, the little battery light, whatever you want to call it, see if that thing comes on. If it doesn't come on, for whatever reason, you need to find out why. So back in the early 70s, whenever some of the GM cars would have a bad diode in the alternator, you'd switch the vehicle off and the charge light would stay on because it had a bad positive diode in the alternator. I hadn't seen one of those in a very long time for obvious reasons. But anyway, this right here is where we're going to start out on this. I had this $1,700 Midtronics tester that I had at the college over there that you could go through the whole charging system test. It had you basically, switch it off. It would test the battery. You had to tell it how many cold cranking amps it had. It would test the battery, and then it'd have you turn on the key. There was a surface charge on the battery. It'd have you turn on lights and stuff and take the surface charge off, and then it would have you start it up, turn on it'd have you turn, well, without accessories on it, have you rev the engine up. And then it would measure, and it would tell you to let go of the revving the engine up and have you turn on the loads like your blower, your air conditioner, your lights, and all that. And it would check it again. So it would check it loaded and unloaded, how many amps it was putting out and that kind of thing, and it would look at volts and amps. Anyway, it would give you this nifty little printout right here. This is a cool printout because it will basically give you a little paper trail on the tests that you did on this thing, and the little printer was separate from the tool, so you had to basically hold the tool. It also wanted you to check battery temperature by pointing the little thing at the battery whenever you were getting ready. So it needed to know all of that stuff, and it had settings for testing the battery out of the vehicle and testing it in the vehicle, and it asked for all kinds of information. And I would run the students through testing the charging system with that. Now, most of the time, what we would do is we'd basically throw our voltmeter on there, and if it was all 14.5 volts, we'd think we were okay. And as far as the charging system goes, now batteries are, the battery is a sort of a wild card in that deal, because you really don't know what kind of shape the battery's in unless you are checking it the right way. And I like checking batteries for cold cranking amps. There's a whole bunch of other ways you can do it. I've talked about that on here before. You don't want it to go below 9.6 volts whenever you're spinning it for 15 seconds. If you got the ignition disabled or something, at 15 seconds. If it goes below 9.6, it's not sufficient for that car. It stays above 9.6, even if a battery test might fail it at the parts store, if it stays above 9.6 when you're spinning it for 15 seconds, you're probably going to be okay. There's some other elements you need to consider there, but the long and the short of it is that's pretty much the way that works. Now this one right here, if you look, it had showed the state of health. It's got a little needle over there on this little gauge, and it showed the voltage was 12.81, 716 cold cranking amps. It was rated for 675. This was a test that was done on a relatively new battery. You don't typically see a battery that's very old that's going to read higher cold cranking amps than what you saw on it when it was a new battery. And anyway, the state of charge is here. You got state of health and state of charge, see? All right, on this one here, the starter test, when you were spinning it over, it would time how long it took to start it. and basically it gives you your loop ohms, you know, it has a way of measuring that. And 188 amps is what the starter would pull in, and your voltage went down to 11.3 during this 1.43 seconds. You see, and it's even give you a little graph there. It's pretty slick. All right, and so this one right here, notice it caught a bad diode according to this. And notice it had to see how that ugly little Bart Simpson heads there is jumping around. It's not really supposed to look like that. So that was a cool little test. But now that is a Midtronics. That was I don't know how much one of those testers cost now, but it was $1,700 whenever I had to college buy that. You know, when I had a grant and I bought that, and it was pretty doggone cool, really. Now my BT608 Altel will enable you to get a report and email it to your customer or yourself or whoever as a PDF. Now this is on a 2019 F-150. I had my BT608 with me one time when I was at the tire store, and I knew a guy that owned the tire store. He said, "Can you look at the guy's truck? Because it kills the battery within 2 days when it's parked." The battery had been replaced with a new one. I tested it with BT608, and it said the state of health on the battery was bad because it was the capacity was supposed to be 750 cca, and it only measured 199. You notice the temperature of the battery was 91. State of charge was 67%. All right, so it's basically giving you a state of health was saying that battery was unhealthy. Now, that's probably because the guy had run the battery down a few times. If you run a battery down a bunch of times and then keep jumping the vehicle off, every time you have to do that, if you run it down too many times, you're going to have issues with that battery. I don't know how many times I've had batteries replaced under warranty. One thing my students knew how to do really well at the college was they knew how to jump one off, because our batteries were dead all the time over there. Well, they could really get good at jumping off a car. Then the cranking, see this basically, it was doing the same thing the Midtronics tester was doing. Cranking was normal. It basically had a little spike when it first started spinning the engine, and then it dropped off. And the starting current was averaged out at 256, which is pretty, it's a big motor in that truck and all. Starting time was 0.6 of a second. It started really fast. Starting voltage never got below 11.56. But look at that raggedy thing there. Even though it says charging is normal, it's basically looking for how much the voltage goes above and below zero. Now it's going to zoom in on that graph on this particular tester so that it will be able to show you something that you can basically look at and analyze. But you notice 7 millivolts is the only amount that it went above. In other words, from here down to here was only 7 millivolts. And it kind of like that. Load current was 6.37 amps. No load current was 9.23 amps. That's a little bit unusual because usually whenever it's loaded, you're going to basically have a even higher, But it turned out that this guy's truck, at the end of the day, had a trailer brake controller under the dash that he had mounted, and that trailer brake controller turned out that it was killing his battery over a couple of days. Got that trailer brake controller hooked up the right way, didn't have that trouble anymore. This was my 2007 F-150. This thing here went smooth and by the numbers, except, look at that. It says output too high, and it was given on a no-load voltage, it was getting 14.6. But look at that beautiful ripple. Isn't that gorgeous? I showed you all that one time before on here. No-load current was 10.5. Load current was 8.79. Starting time was 1 second, 230 amps, average. It's going to average that out, see. The spike when it first started spinning, the motor always goes up and then it levels out as the engine spins, and it averages this with that, and it came out with 230. If you actually were measuring this over here, you'd probably see a whole lot lower amperage reading than that. Starting voltage was 11.48. But that one, again, this says the output was too high, but it's not high enough to bother anybody. I had a motorhome one time that had a F-53 chassis motorhome. They buy the motorhome manufacturers buy the F-53 chassis from Ford, and they would build a motorhome around it. This one was overcharging. Give it a little bit of gas, wham, it would go up to 18 volts. Typically, that's a voltage regulator issue, but it can, there can be an internal short in the alternator. But in this particular one, I put an alternator on it, I replaced the voltage regulator. I got under there and I put a voltage regulator on it. Of course it came with new brushes and all that. But it did exactly the same thing. And it turned out that particular alternator, when the centrifugal force would throw that thing out, it would actually full field itself. That's the only time I ever saw that. But I figured out that that had to be what it was, and when I put an alternator on it, took care of it. So overcharging is not good. This is my 06 Explorer. Now look at this one here. I think I may have, it's got that battery cover on it, that the battery cover, that plastic battery cover is there to keep the battery from getting too hot with engine temperature. It keeps it a little bit cooler. And so basically that battery capacity, I think it should have been 750, because I couldn't see it because the battery cover was over it, and I just guessed at it because I think 850 is what that thing's supposed to have in it, but it's got a Motorcraft 750 in it. Anyway, since I told it it had 850, it didn't like that. This is 20 degrees Celsius. It didn't give it to me in Fahrenheit. I should have set that up differently. Voltage was 12.7 and 698. State of charge is 100%, but the state of health put it down there in the replace range. Although I sort of blew that off because 698 cold cranking ounce is just fine for me on the 4-liter Explorer. Normal cranking gives us 214 average on that one. Starting voltage. Starting trying 0.93 seconds. Now I will tell you that my Explorer has got a little bit of pressure leak back through the fuel pump. An interesting thing about the Explorer is it's a returnless feedback fuel system, so it's got a fuel pressure sensor on the fuel rail. And it's basically going to be using a module to determine how much to run the pump. So when I get in it, if it's been parked a little bit and that pressure's bled off, and I just spin it over and try to start it, it spins longer than I like for it to, which that's not good for the starter either. But so what I do is I switch the key on 2 or 3 times, and every time when it's quiet, when I switch it on, I hear that fuel pump go wing. But if the fuel pressure comes up to where it should be in the rail, the pump doesn't run. Like it used to do a 2-second run on all these things, but it would run for 2 seconds. I switch it off, it may run a half a second, and the next time it wouldn't run at all because the pressure was where it needed to be. See, it's a smart system. Anyway, so I turned that on, I pressured up the fuel rail, I started it up, it started in less than a second. Look at the no load voltage, 14.22. Now let's look at the truck, see 14.62? Alright, 14.08, 14.34, see that one's higher all the way around. No load current's 4.47, not load current's 3.36. But look at that. This is 178 millivolts. See how it's ragged looking? Like that right there. Alright, now let's go back briefly to that one there. Look at this one here. That one there was 336 millivolts on either side, whenever you go above and below. Alright, now, I like to take a time and talk a little bit about this one. I think I've told about this one before. This customer had replaced a whiny, noisy alternator himself because it was real easy to get to on this 88 Ranger. And so he replaced that, and right after he drove it, a little while smoke came from under the dash. Customer returned the alternator to the parts store, blamed the alternator, and told AutoZone, and AutoZone was really good about this. They said, well, let's go ahead and let you take it to the Ford dealer, and if they tell us that our alternator messed it up, we'll pay for whatever needs to be fixed, which I thought was more than fair. So I said, I need the alternator he originally purchased, but I need his old alternator back on there. And the guy put his old alternator back on there and brought it in there, and that thing was whining, and it was noisy, and it was smelly, and it was just terrible. And so, but anyway, this alternator that he had bought, which they still had, I replaced that original noisy alternator with the one that he had originally bought, and with the tester, and this was a Mac tester that you couldn't even get anymore, but we bought it brand new for like $1,700 back in, when I was at the Ford dealer. The VAT 40 died, which was a tragedy because nobody's ever made a tester that's any better than a VAT 40. You old timers will know what I'm talking about. Anyway, this one here was okay, but that diode light would come on. If you tested a system with a bad battery, you'd get a diode light that would lie to you. So I couldn't totally trust this to tell me if I had a bad diode. The VAT 40 never failed to identify a bad diode when it threw that needle up there where it's in the bad diode area. This one here just had a light for that. And the snap-on one that I had over at the college had some little lights that would dance around for good, bad, whatever. Anyway, the point is, this one right here had slightly less than 12 volts with the engine running, and it was pulling 27 amps while not using the carbon pile knob. So I had lower voltage than I was expecting here. I expected to see this needle up in this area somewhere, but it was way down here, and I was seeing amperage here, and I was thinking, what the heck is that all about? I don't get it. This didn't make any sense. Well, I started seeing smoke, and when I got under the dash here, this had burned that carpet. It had cooked those wires. It burned up the inertia switch. And so I replaced the inertia switch. I replaced the connector, because you could get that those days. Sometimes the the terminals going through that into that inertia switch would get oxidized, and they would cook and burn and melt, and the inertia switch would open up, and you wind up having to replace that. This one didn't have that problem. It basically just, I figured, well, maybe the inertia switch had picked up some resistance, and it heated all this up. You notice it would get hot enough to where it actually burned that carpet. You see that? Okay, so I went ahead and replaced all that. I fixed it. After I fixed that, got good connectors, got good connection there, got good strong wiring going out there. I saw flames in the engine compartment after I ran it for a little bit. It didn't smoke from under the dash, but I saw fire under the hood. And this fuel pump relay literally caught fire. And I'm telling you, the flames were like, way up above the fender. It was like bad. Scared the daylights out of you, And you know how it is, if one catches fire while you're working on it, they want you to fix it for free. But anyhow, I'm talking about the dealership would make us fix one if we set fire to it. I usually set fire to about one a year for some reason or other. I didn't. It wasn't always for the same reason. But anyway, the flames in the engine compartment on the right side. Shut the truck off, grab the fire extinguisher, put it out. There's your fuel pump relay right there. And that down there was your power relay. But that fuel pump relay had really got hot. I said, wow, that's a clue right there. So I went ahead and I got the new connector that you could get from the parts room. They had them in stock, and I got my fancy little tool I've showed you before, and I put all that back together. So I had fixed this. See the solder in the heat shrink, man. It was a good job that I did on that thing using high quality stuff. This air got a little melted. That was the AC relay, the wide open throttle cutout. I wasn't going to replace that just because it didn't look good, because it still worked okay. This one right here was the green one is your fuel pump relay on those older ones, and the brown one is the power relay. The black one's going to be the one that's your AC wide open cutout. So I fixed that up, and so what I found on this thing after I got to look at that connector right there that was going through this fuel tank selector had started to melt. Well, the problem was this fuel pump, this transfer pump, which is basically just like a windshield washer pump, only it feeds that big pump that's on the frame. They did that until through 1989, and in 1990 they got smart and they put higher pressure pumps in the tank, and they did away with that frame mounted fuel pump. Alright, and so basically there was a tank selector switch here, and those are two diodes in there, and that little motor in there would basically go and change it from one tank to the other, and there's your electrical part of it. And it would also change it so that it would change the power going there, but the fuel gauge basically was switched from one tank to the other too, which was pretty cool. They did this a different way later on, but this is how they did it way back then, and to have a Ranger with two tanks was unusual anyway. Alright, so right here, this melted, and I got to checking, and I found out this inline high pressure fuel pump, it wasn't the problem, but that one there was. It was pulling 40 amps. It wasn't supposed to pull but only 2 or 3 amps. But the windings in it were bad. It was going to cost him $125 for a replacement in-tank fuel pump for his front tank. His rear tank did not pull that many amps. It did just fine. And he go ahead. I told him, I said, this was basically, you put a stronger alternator on there, and we found the weak link in the chain every time. The first weak link was the inertia switch. The second weak link, when I strengthened the first weak link, the next weak link was the fuel pump relay, and it's caught fire. And anyway, I tracked it all down, and that explained this. This right here, I had a load. This is only showing about 26 amps, but when I measured the fuel pump, it was pulling 40, and this had pulled that down to 12. See, it's like you're turning your load knob, only the fuel pump was the load. Okay, and so that took care of that. Now, this is a 2005 Pacifica. See, I scope tested that one there, and it's got you can actually do that with amps or volts. It works either way. And you can get it. If you see an ugly pattern like that, you typically got some issues with that. You may also hear a noisy whining alternator. Sometimes you might think it's bearings and all, but if it's hot and stinky and sounding like that, or if you look at those windings in that alternator and they are scorched and ugly and black, if they're pretty and shiny and copper looking, you probably don't have an issue with the winding, but you may have a diode problem. Alright, so just keep that in mind too. This is one of the ways you can teach batteries right here. This is a new coal cranking out level in a battery. You notice I got the pump charger pumping water out of the ground into the tank, right? So it's going to be, it's making a circle the way I'm teaching it right here. All right, I drew this myself. You got a valve right here, which would be a switch. All right, you turn that on, you're going to see the turbine that the water is going through spinning at is going to be your load, whether it's a bulb, whether it's a motor, whatever it is, and it goes back to ground through that load, right? Obviously, if you stop up that load, this is not going to run. That's what like you're having a bad ground. All right, so you basically are doing that. But the longer you run a battery, in other words, if you've got it in there a couple of years later, you're not going to have as many coal cranking outs. You're just not. It's just all there is to it. And so then, the longer you run it, the lower the coal cranking outs get. It eventually gets to the point that it will. You might have heard, I heard my neighbor's vehicle out here, whenever they start, the one car they've got, it goes, run, 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 boom, then it starts up. You can tell that's getting really low. Low voltage, by the way, if you're consistently got low voltage because of a voltage drop situation on the cable or something, you will burn up a starter with low voltage. Because it's kind of like the starter's locked up, you know, it's being told to do something it can't do and it just gets hot. Now this Autel BT608, I broke it out yesterday. And see, it's telling me whenever I told it it had the 850 coal cranking out battery, it's squawking, telling me that it didn't like that battery. It told me to replace it and all that. This comes, you got to order this separately from this. If you're getting the Autel, you will not get this little hookup right here that enables you to use it for a voltmeter, which it actually has got a tracing meter, kind of like a scope built into it. It'll do. This little tool right here will do relative compression tests. It acts as a scan tool. It'll scan all your modules. It does amazing things for what you're paying for it. This sucker here is worth the money. But anyway, what I did was, you know, you got to hook up to your battery. This right here, one of the things that I like about this, the outstanding thing about this one, and it's the one I bought, the kit that comes with this and the leads for the measuring voltage. See, this comes with it, but I'm talking about the lead for measuring voltage, like if you're going to use it for a graphic voltmeter. That costs $250 in addition to what the tool costs. By the time the smoke clears, when I bought this one, then you got about $850 invested in it. But for what this thing will do, it's worth every penny of that. Unless you're a do-it-yourself person and you don't want to spend a big ton of money on it or something like that. Anyway, I hooked that thing up. One of the things you got to look at here is batteries can explode. So anytime you're working around a battery, put you some safety glasses on. I've had them explode when I was working on them. One time I had mine had an explode. Didn't have safety glasses on, but I just happened to have my arm in front of my face when that thing blew. Put a wrench on that, made one turn, boom! Something happens inside there, it'll light that stuff up, and it blows it up, and that's what happened to that one right there. All right, this amazing alternator. The alternator is an incredible generating device, is what it does. Of course, you know it makes alternating current. It runs it through a rectifier bridge and turns it into DC current. But it spins its magnetic field through the stationary outer winding, which is called a stator. Anytime you've got a winding that doesn't move, they call it a stator because it's stationary, right? All right, so this thing right here has got this little claws on it, and it goes back and forth. And that's what gives you that little ripple every time those things go through there. And you got 3 windings in here that are tied together either at the corners or in the middle. And they're basically whatever, you know, if they're tied together at the corners, those 3 corners are connected to the diode trio. It's actually got 6 diodes in there, and then you hook it to the middle of those diodes, and they're making the current all go in one direction. All right, so the brushes contact right here. Now, whenever like Visteon, when they rebuild an alternator, they measure the diameter of these, and they make sure that it's like brand new. A lot of the other manufacturers just throw a set of brushes in it, clean it up with a bead blaster, and put it back out there for sale if it's a reman. The brushes make contact there. The rotor and the stator don't touch, but the gap between them is only about 40 thousandths of an inch. Furthermore, when this winding is wrapped around a core, that metal core intensifies how much that thing is able to put out. So this thing is really a sort of a stud, and that one there's got an overrunning pulley on it. But this thing can spin as high as 14,000 RPM. You know, so. Now, similarities and differences, there's your Chrysler Dodge. You notice on your Chrysler Dodge, your automatic shutdown relay, which powers up the injectors and a bunch of other stuff, basically is going to go and feed the generator field, right? Powertrain control module is also fed by that. But that generator field is completely controlled by the powertrain control model. That's as slick as a button because the PCM knows what the battery voltage is. And so why not? That's real simple. You got an alternator with no internal regulator. Basically you got a little noise capacitor right here. And that thing right there is, you know, you're grounded. There's your, see how this stator I was talking about, the 3 windings, those are tied together in the middle, and the outside is connected to those. Now if it's made that, if it's a delta wound, which is, you know, got the wires tied together at the ends, the 3 ends are hooked to those 3 diodes. But see, the end of those hooked each one to a separate diode set. And this right here, it doesn't look kind of like what you're looking at here in the picture, but this right here is the field, which is the part that spins, and this right here is the stator, which is the part that's like that. Now you can't see the diodes in this one here, but that is really pretty cool, and that's, you know, sort of an older die, just been out there like that for a long time. General Motors, this is a newer model GM, like a 4.8 or 5.3 or something like that, and that big battery terminal is going over feeding the battery. This is one of the starter. And obviously this thing right here, the instrument panel, notice the charge indicator, what part it plays in here. This goes to your computer data lines. And your generator field is also controlled on this one. So you got a big wire coming off, and this one right here is your generator turn-on signal, which is very interesting because that does the same job. But usually that turn-on signal comes through the charge light on the older ones. I'm going to show you that in just a minute. Alright, you can still see that, I guess. Alright. That's your engine control module over there. So it's basically a talking on the data bus. The generator turn-on signal is basically just a little 12-volt signal. It actually grounds that if it quits putting out, and when it grounds that, the bus tells the cluster to turn on the charge indicator if a ground is fed back through here by that. You know, that one in there is the regulator is built into here, but that's an interesting thing that you got a turn-on signal because it's kind of like all of this is working together. There's some kind of electronics in there. I didn't dig into that, but you can see how what I'm looking at is by looking at schematic. Now this is Ford's then and now. Back in the day, this generator turned on. This is if you cut that wire, the alternator won't put out. If you ground that wire, this light will be on all the time, but the alternator won't put out because when you ground the wire, you know, there's no voltage going down there. That's your turn-on signal right there. Now this 470 ohm resistor that goes around it is there to keep this circuit working, keep the alternator charging. If this light bulb burns out, they want it to be able to feed some voltage down there to turn it on. Now I had a guy one time that had rented a car, and he took the instrument cluster apart trying to roll the mileage back, and he tore the printed circuit, and when you switched on the key you didn't see that light, and the wiring was real good all the way up there, so I had to pull the cluster apart and order a printed circuit for it because of the yo-yo trying to cheat the mileage, cheat the rental company out of their miles. Now this right here, you notice over there, you got your B+, that's your big one going over there. And this right here is, notice that little jumper that goes around right there. Look at what that does. Now if you look at the way this is wired up right here, that jumper, that stator wire, comes from just one leg of the stator in that Ford alternator. And whenever it jumps around, it's white with a black stripe actually, it jumps around there, and that field, you can actually get on that regulator with that field and you can measure it with your scope or whatever and see what's going on in there, because the field is basically being, this electronic part's controlling the field. That's your yellow-white. That's the sense wire. Got it? That's the one that senses how much battery voltage is in there. If you have a voltage drop situation on this wire, and I've seen that one time, then it'll have enough juice to run the alternator, but it'll overcharge because what it's reading right here is what it determines, how much field it determines to give the alternator. And there you got this 30 amp fuse going through the orange light blue on that one right there. That's your A terminal. Well, excuse me, I screwed up on that. This is the one that charges the battery. This is the one that's the sense wire. So that one right there, the charge actually goes out that wire. This is the other one that can have voltage drop. And if it's still got like we were saying, this one's showing 12.5 volts or something like that. And it's going to keep on energizing the field, trying to get that voltage that it reads right there up to 14.5. If it can't make it, the actual voltage it's feeding the battery is going to be really, really high. You notice they got a fuse in there on this 99 Taurus, that if it, if it pops that fuse. So if you go to the alternator and you measure that big wire and there's no power there, you don't need to replace the alternator until you find out why there's no power there. Occasionally I've seen a parasitic drain that you could disconnect the battery and the parasitic drain would go away, and that would tell you your alternator is bad. In other words, you disconnect that B plus wire. Now this 2020 Ford Edge is a different study. See, there's a generator current sensor on that one that's measuring the current. Now a lot of them will measure the current on the other. In other words, they'll measure the current on the negative side on that one right there. But anyway, there's your current sensor. Notice you're not seeing the battery anywhere in this schematic right here, but your battery monitor is right there. And so there's your generator feeding through that junction box. So you got 275 amp fuse. That's basically going to the battery over here where you can't see it. And you notice you got that wire right there. That's a 10 amp fuse coming through there, and it's basically the sense wire. That is the one. That's your turn on wire right there. And then this one right here is I'd have to dig into that, but you can usually figure this out because it's very similar. You notice you got several wires going to that thing. Actually, this is going to be your big one right here going through that, and this will be your other three little wires. So if you look at the A wire, which one of those is going to be the A wire? You see, you got a 1, 2, 3 here. This one right here is the I wire, but that's only hot when you turn on the ignition. Okay, so gen light is going to be generator light, and that's going to be your sense. This is going to be your sensing wire. The sensing wire on this one's the same one that fed the brushes. And they may have a different one on that one. I'd have to dig into that. I just pulled the schematic up and looked at it a little bit. On a Toyota, you got a 99 Camry here. So look at there, they gave you all this. Look at all those diodes right there. They basically have a really cool little setup right here. That right there is your field that spins. This is the stator, and this is a Y-wound stator right here. And there's your voltage regulator built in. And you notice on that, look at this, your charge light's going to be turning it on. And then basically you're going to have a sense wire. This one here is going to be the one that feeds power to the battery. And you can kind of figure that out. But look at that, you got a 100 amp fuse on that one right there, and that was in 1999. And so look at the similarities between this. Now this is the 2019 Camry. We've jumped up many a year here. Look at that. How far is that? That's 20 years, isn't it? Okay, so basically, is that 30 years or 20 years? 1999, 09, yeah, that's going to be 20 years. Because if it was a 2000 and a 2020, it'd be 20 years. Boy, how my math got me all screwed up. Now look at that one there. See, this one here has got a battery terminal coming out, going through a 120 amp alternator fuse, going through a fusible link right there. Of course, there's other stuff coming off of that. And your combination meter assembly has got computer data lines. And then you might notice on this, on your ECM, the light, you got that right there going in. That's basically going to be the one that, kind of like on your GM vehicle, that triggers the generator to start putting out and all that. And there's your computer data lines. Look at this Nissan here. You got a charge light on a Nissan doing the same job. It's going in there, basically turning it on the regulator on. And that one right there, your blue-black one, that's going to be this one's a ground right here. And that blue-black one's the one that's going to be feeding the power to the battery. You can follow that. And this one right here is going to be your sensing wire. And may probably feed the brushes too. And so, but this, look at this one over here. This is an amazing thing here. Look at all of that schematic, all that stuff. The charge light is still part of the deal here, but it's not directly connected to anything other than by way of the computer bus. The data bus on that. And so look at your alternator. Where does that's got? See, it's got that light, that same LIN. It's going to turn that thing on right there. It's going to trigger it, and this is going to the starter, and then it makes its way up to the battery through that 450 amp fusible link. Got that? All right, and that's an 80 amp fusible link right there. And so there's a whole lot more to that one, but the starter is typically in there somewhere. They like to do the junction at the starter on a lot of vehicles. They'll actually let the alternator go. They want a good solid connection with a nut and a copper lug and all that kind of thing. All right. What did you learn? This was not a long video, but it's fairly intense, and I just need to know what you guys thought of it, and I'll talk to you next time.